So now that we've dealt with exponential functions with bases other than e, let's start taking a look at the idea of finding derivatives of logs of bases other than e. So I want a derivative of the form log base b of x. Now, as you may recall, from common notation, log of x, whenever you write it like that, the base 10 is actually understood. So if I need a derivative, d dx, of something in the form of log base b of x, this is going to be simply equal to 1 over x times log or ln, natural log of b. Now that may seem kind of magical, but really, when you look at changing base, this becomes suddenly obvious. And as a algebra review, log base b of x I can write as the natural log of x divided by the natural log of b. So the derivative, d dx of log base b of x, is actually the same as the derivative d dx of the natural log of x over ln b. Now ln b, remember, because b is a number, ln b is a number, it's just a constant. So that's just going to be 1 over ln b times the derivative of ln x. Well, derivative of ln x is 1 over x. So this is going to be 1 over ln b times x, which is what I claimed it was up here. But when you actually change the base, go from log base b of x to changing this to natural log, or the natural log base e, then this is the change of base formula. Now just take the derivative of this, and bam, that easy, you're there. So let's take a look at a couple examples here. I need the derivative of log base 2 of x. Now, based on that formula we just showed, this is going to be 1 over the natural log of 2 times x. And obviously, you can pull the x out here if you like it. And I'm going to rewrite this just so that, again, it doesn't look all that magical. Change of base, this is ln x over ln 2. Now if I take the derivative of log base 2 of x is the same as the derivative of ln x over ln 2, which is 1 over x ln 2. It doesn't really matter which way you write these things. This may be a little bit easier. I don't know. Pick one. It's no big deal. Okay, so this could be the exact same idea, only this is base 7, and I no longer have an x. I have a polynomial here, so I need to consider this in the chain rule when I take my derivative. Now, to do this, I'm going to go ahead and rewrite this. I'm going to change bases so that you can see it a little bit easier. This is the same as d dx of the natural log of x squared minus 3x plus 2 over the natural log of 7. There's my base 7 right there. So the derivative of this is just a constant. This is going to be, the ln 7 is going to sit here. So the derivative of ln of the polynomial is going to be 1 over that polynomial. So I'm going to have x squared minus 3x plus 2 times this thing prime, x squared minus 3x plus 2 prime. I need the derivative of that. So that's going to give me 2x minus 3 over ln 7 times x squared minus 3x plus 2. So in general, d dx of log base b of g of x, because that's what this is, b is 7 and this is g of x, is going to be equal to g prime of x over b times g of x. That's exactly, like I said here, I need to make a quick correction. That's ln b. I just kind of threw that b down there by itself. Sorry about that. And this right here is exactly what we did here. It's the same thing. It's just written in a generic form. So let's go ahead and take a look at another example here. I need the derivative of log base 10 of sine x. Well, that's going to be equal to the natural log of 10 times sine x with a numerator of sine prime of x, the first derivative of x. So that's going to be cosine of x over the natural log of 10 sine of x. And then that, of course, is cotangent of x over the natural log of 10.